Question 14. Expressed as a product of prime factors 408 equals to 2 cubed times 3 times 17 and 3060 equals 2 squared times 3 squared times 5 times 17. Use the above results to find the smallest integer k such that 408k is a perfect square. Okay, so before we even start to look at the question, first of all, the term perfect square. What does that mean? So I put a note 1 here, that perfect squares can be written as a product of prime factors with even powers. So for example, 49 equals to 7 squared. 7 is a prime factor. 7 square, this 2 is your even power. Okay, another example, 144, if you express it as a product of prime factors, you have 2 power 4 times 3 power 2. So these are prime factors and the powers are even. So these are examples of perfect square. Alright, so all perfect squares can be written as a product of prime factors with even powers. Alright, second point to note, that here we are looking for the smallest integer k, so that 408 is a perfect square, which means we are looking for a smallest perfect square. Alright, so now we go back to the question. We are supposed to use the information. So we note here that actually this information is redundant. We need not use this information. 3060 equals to 2 squared times 3 squared times 5 times 17. This is not relevant, so we can just simply ignore that. Alright, and we just make use of this piece of information. 408 is 2 cubed times 3 times 17. So in order to have a perfect square, we will have 408k written as 2 cubed times 3 times 17 times a k. So remember, we are looking for the smallest perfect square. So smallest perfect square following this number will be 2 power 4 times 3 squared times 17 squared. Because remember, these numbers have no square. So if you want a perfect square, you have to make all the powers even. So the smallest one is to simply increase this power 3 to power 4, increase this power 1 to power 2, and increase power 1 to power 2. So this is your smallest perfect square. And this smallest perfect square can be equated to this one. Right? So if you do a comparison, you know that k must be 2 times 7 times 3 times 17, and that gives you 102. Right? Now for part B, it's a word problem. So we'll focus on that. In a shop, candies are sold in packs of 42. Marshmallows are sold in packs of 60. Jean buys the same number of candies as marshmallows. Find the least number of packs of marshmallows that she could have bought. So we first note that 1, candies are sold in multiples of 42 because each pack consists of 42 candies. So they are sold in multiples of 2. If you buy 1 pack, you have 42. If you buy 2 packs, you have 42 times 2. If you buy 3 packs, you have 42 times 3, and so on. So multiples of 42. Marshmallows are sold in multiples of 60 because each pack consists of 60 marshmallows. So if you buy 1 packet, you have 60. You buy 2 packets, you have 120. 3 packets, you have 180, and so on. Right? Then you are supposed to find the least number of packs of you buy the same number. That means the number of candies and the number of marshmallows are exactly the same. So the same number of candies and same number of marshmallows, but the number must be the multiple of 42. This number is also a multiple of 60. So we are looking for multiples LCM of 42 and 60. So the total number, the same number of candies and marshmallows bought will be actually the LCM of 60 and 42. So we solve it by first finding the LCM of 42 and 60, break it up into factors. pick up 60 to be 2 square times 3 times 5. So the LCM will be 2 square times 3 times 5 times 7 gives you 420. So Jean bought 420 marshmallow and 420 candies in total. So the question is asking for the number of packs of marshmallow that she bought. So the number of packs of marshmallow will be 420, which is the total number of marshmallows bought, divided by 60, which is the number of marshmallows in one pack. So 420 divided by 60, you get 7, and this will be the 7 packs of marshmallows. That's the answer.